Here is a Kenwood model KX-710. First of all, let's give this a quick test. I have this hooked up to an amplifier. So if I apply power, ooh, there is a lot of noise. That's not good. Let's put in a cassette and start with fast forward. Okay. I think that is supposed to be a bit faster than that. So that might be a bad idler wheel. Let's turn this around and try rewind. Ooh. Yeah, see, rewind doesn't work at all. It's trying, but it doesn't succeed. And for some reason the cassette deck cuts all the noise when you press rewind. Huh. Okay, let's maybe if we reverse the cassette once again. No, still no rewind. So yeah, that has got to be just a bad idler wheel, something like that. Let's try playback. Oh, that's really loud. Okay, we have an output here. Ah. As we turn that down into the center position, the noise disappears. So I guess you're supposed to have this in like the center position, not on maximum. Let's try again. Oh, take-up reel doesn't turn. Okay. Use fast forward to take up the slack and, well, try again. Okay. Well, there is audio, so the amplifier does work, but take-up reel doesn't turn, so we'll have to take care of that before we go any further. I turned the machine upside down to take it apart, and look at that! There is a warranty confirmation label on here, and it says this machine was sold on the 17th of August 1976. Here is the cassette deck with the bottom panel removed, and straight away we can see the main belt. God, look at that. This is in terrible condition. I'm quite surprised that it managed to work at all. So I can see in all four corners there are screws, and they are looking kind of worn out. So I think if I remove them, I should be able to take this entire chassis out of the case. Turns out there are 3 more screws than I thought. There is one down in here, one down there, and by far the most difficult one to find is below all these cables in there. And finally, the chassis is out. Of course, you have to take off the slide switches. You also have to take the knob of the voltage selector in the back. And after the chassis is out, I would recommend using some sticky tape to tape the meters in place, because these are completely loose once the chassis is out. So it's easy to damage them if you just leave them flopping around. The next step is going to be taking out this back plate of the eject mechanism, and it doesn't seem like there is any way to release this where it sort of locks into the mechanism, so I'm going to take off this C-clip there, take out this metal rod so that I can hopefully take this entire thing off at the hinges. The eject mechanism has been removed. That was not easy. But now we can finally see where our problems are. So this right here connects to the flywheel via a belt on the other side. So this is turning. If I now press fast forward, this is pushed against this idler tire, and that then turns the take-up reel. And that's your fast forward. If I push rewind, it all moves over, and now this drives via this idler wheel here the idler tire right there. So it turns the supply reel, and that's your rewind. So that's all quite simple. Now, if I press playback, this doesn't do anything. This is disengaged, and that is because the take-up reel is driven directly by the capstan via this belt down here. And you can probably already tell this belt is in absolutely terrible condition. This is completely loose. So that won't do anything, and that is why the take-up reel is not turning at all in playback. Now, I have already gone through and checked the idler tires, these rubber parts, and they all seem to be in very good condition. So we may be lucky and manage to repair this entire deck, including the weak fast forward and rewind, just by replacing all the belts, including the belts on the other side. After removing these 3 screws in the back, this plate comes off like so, and there is the back bearing for the flywheel. There is the flywheel, that's nice and big. And here we have the first bad belt, the main belt. Actually, it doesn't stretch, it's just loose, very loose. Here is a second belt, and this is quite surprising. You know, this belt, either they got it from a different supplier or it has been replaced before, because this one is actually in really good condition. Nothing wrong with that. We have another idler wheel right there, and also in this one the rubber tire seems to be fine. Looking at the mechanism from the other side, I forgot to mention previously, there is of course a friction coupling in between here, because also in fast forward and rewind, when this part is spinning fast, this white part is still going to be driven by this belt, by the capstan. Now, to take out this belt right here, I think the way to do it is we're going to take off the counter belt, which is maybe a little bit loose, but it still seems to be good enough. And then I should be able to fish out the bad belt right here. And I am. Okay. Got to release this brake. And now, see, this is what I can't really see very well. This is of course the front bearing of the capstan, but this is held in place by this part right here. So this entire thing is suspended above the mechanism. There is a space down below, and it seems like there is a pulley in there for this belt. So I'll have to try and fish this belt out of there. Okay, like so. I'll pull it out and then pull it through here. Oh yes, engaging playback helps. And then there is this little catch right here, so we need to go around that. Okay, and that is this bad belt taken out. Reassembly is the reverse of disassembly. At least that's the theory. So now this is such a spontaneous repair project. I don't even have one of these overpriced belt kits for this. So this is just a belt that I fished out of my box of salvaged belts, which was a bit of a mess because one of the salvaged belts had decided to deteriorate. Okay, feed that down into there, and hopefully it's going to find its way onto that hidden pulley. And this one, see, I can press play to disengage the brake. And I'm using these dentist's tools for this. I got one of these tool kits off eBay. And this was really quite a fantastic investment. In the previous take, the belt turned out to be too loose. This one appears to be a little bit too tight. But let's see, is it on? No, it's not. It's still... Oh, now it should be. Okay, and if I turn the flywheel manually, see? Oh, look at that. Look at that. Our take-up reel is working again in playback mode. Here is the old counter belt, and as you can see, if I lay this down all relaxed, the rubber still retains the shape of the mechanism leading up to the counter. So this belt is not that good anymore. And in my replacement belts, I have found this one, which, as you can see, if you just put this onto a surface, it's nice and round. It's also a tiny bit more tight than this one, so I think this should be a good replacement. Okay, let's try to feed the belt through from here. Okay. There is quite a bit of grease along this part of the mechanism, which doesn't help. Okay, so that comes through like so. Let's go and I'll just hook it around there temporarily. Okay, yeah, okay. No, it's not on. If I bend some wires out of the way, I can reach it with my fingers and hold it. Put the belt onto these rollers. Doesn't want to go there. Oh, and this, yeah. This is now lying in grease. Okay. Right, okay, that's that. I'll probably have to clean up this belt. But if I release the brakes, yep, the belt works. As a replacement for the main belt, I found this one. And I first thought, oh, this is going to be way too tight. But it turns out, since the original main belt is so incredibly loose, this is actually pretty decent. It's perhaps a little bit more tight than I would like it to be. But if I turn the flywheel... Oops, well, that's not supposed to happen. Let's try that again. Okay. Yeah, if I turn the flywheel and bring this up to speed, the belt is riding on the crown of the pulley. That's how it's supposed to be. If the belt is too loose or too tight, it will not ride on the crown. It'll actually drift off to the sides, and then the speed will be incorrect. The captive plate is back in place. I put some white lithium grease into the back bearing before assembly. No oil, because that won't stay in place in this design of back bearing. There is the new belt. This belt is still the same, because there is nothing wrong with it. And with almost all the belts replaced, it's time for a test. I have the machine powered up. Let's put in our test cassette and press fast forward. Oh, look at that go. That's going nice and fast. Rewind. That's also working fine. Counter is working as well. Let's try playback. And take-up reel is now turning. Fantastic. I don't have it plugged into the amplifier right now, but you can see VU meter is going quite happily. Counter is running. Well, I guess that's the majority of problems repaired. Fantastic. And finally, the eject mechanism is back together. That was difficult, so make sure you take a very good look at everything before taking it apart. In a nutshell, the record protection goes over this mechanism here. This piece right here, this goes over the plate, and the tape selector goes under this mechanism over here. Well, here is a problem I've never had before. The belt still kept coming off the pulley, and I was starting to think, well, maybe this is too tight, although I don't think so. But then I noticed this. The pulley is completely loose, and if the motor is turning, this just keeps moving around until eventually the belt comes off. Now, this is easy to fix. The pulley is held in place by 2 screws. It's also a good opportunity to pull this thing off completely and lubricate the front bearing of the motor. The cassette deck was running a bit too slow, so I just corrected that using my 1 kHz test tone tape. Now in here we find that the DC motor still has an external speed control board, and on here we find 2 adjustments. So just to be on the safe side, I have marked the original positions of these potentiometers, but it turns out these are actually both speed controls. There is a coarse adjustment and a fine adjustment, and this is such a fantastic setup. I don't think it has ever been easier to correct the speed on any cassette deck I've ever worked on. To measure the frequency, I have used the oscilloscope. You can see the value down here, hopefully. And on these digital storage oscilloscopes, you can take advantage of one of their features to make this a bit easier. See, I have set this to do 8 averages, and that greatly stabilizes the frequency readout. And there it is, the Kenwood Model KX-710, nicely cleaned up, put back together, ready to go again. Thank you for watching.